Hi guys, welcome back to my channel Pirai Academy. In the series of Zoho interview question, today we are going to see about a question called count palindrome words in a string. So they will be given a sentence and we want to count how many palindrome words that are there in the sentence. Fine. What is mean by palindrome words? So for example, if there is madam, then it is called as a palindrome because if I just reverse this, then also it will be what? Madam. Can you understand this? But if it is Pirai, then IARIP. So this is not equal to this, right? So it is not a palindrome, but it is a palindrome. Hope you understand this, right? Now tell me, in the given sentence, what are all the words that are palindrome? I can tell you this madam is a palindrome, and this Aurora is a palindrome, this Malayalam is a palindrome. Okay, and also they have given that it is a case insensitive. Okay, fine. So which means lowercase is equal to uppercase. So which means capital A is equal to small a. Hope you understand this. That's why this Aurora and this madam are palindrome. So we will be returning what? 3. Hope you understand this. Fine. Now how to do this? So the basic brute force approach. We can go with the basic brute force approach. What's the basic brute force approach that we can do? So first step, we want to just split each and every words, right? So split or extract each and every words and store in an array or list. Okay. So we want to extract words. Fine. Now you can go and check whether what are all the words that are palindrome. So check for palindrome. Okay. And if the current word is a palindrome, just add it to the result and return the result. That's it. So these are the 3 steps that are involved in the brute force approach. So it's a basically easy brute force approach, right? Because to extract each and every words, we have an inbuilt function, split function. Okay. By using these all, we can do it in a simpler way, right? But its time complexity going to be high, right? Because its time complexity will be like for splitting each and everything will be O of n, and then for checking the palindrome is also O of n, but the space complexity will be O of n because we are just storing them in an array, right? So there will be some space complexity. Now we cannot optimize the time complexity further, but we can reduce this space complexity further, right? So how we can reduce the space complexity? So let me take the example again. Okay, fine. Now every words will be having either a space next to it or it should be the last word. For example, for this madam, there is a space, right? For this Aurora, there is a space. For this teachers is a space. And this Malayalam is the last word. So from this observation, I can tell you that every word will be ending with a space or else it will be the last word. Okay. By using this clue, I can tell you that we can easily find the words that are palindrome and we can count it, right? Because see here, I can say that at this space, from this space, I can tell you these are all the one words, right? One word. So I can just do a palindrome algorithm. How I am going to apply a palindrome algorithm is something like this. So initially one pointer is here, another pointer is here. Okay. Whether these 2 pointers character is same, yes, it is same. Then I will be just moving ahead. Whether these 2 are same, yes. Now moving ahead. They both are met. If they both are met or overlap, then we will be stopping there and we will be telling that the current word is a palindrome. If any 2 points are not same, then it will be not a palindrome. Hope you understand this approach. Okay. So from here. So listen this carefully. From here, initially I am here, right? And again in another pointer I will be traversing ahead. So I will be traversing here. So M is a space, no. Whether A is a space, no. Whether D is a space, no. Whether A is a space, no. Whether M is a space, no. Whether this space is a space, yes. So if this is a space, then I will be looking ahead a pointer. So I will be just making here a pointer. Okay. Now this white pointer and this blue pointer are same. Yes, it is same. Then just move here. Now again, whether these 2 are same, yes. So move here and move here. Whether now it is overhead or at the same point. So stop here and make this a palindrome. So my result will be now adds up now is 1. Now you may ask, this is a capital M and this is a small m. Why these both are same? Because they have clearly stated that it is case insensitive. Okay, so if it is case insensitive, we can do it in a two ways by converting both characters to uppercase. By converting both characters to uppercase, or else you can also convert to a lowercase. How you can convert to uppercase or lowercase? By using inbuilt function. Or else you can also do this without using an inbuilt function, like lowercase minus 32, which is equal to uppercase in a ASCII value. Or else you can use uppercase plus 32, which is equal to lowercase, to convert into lowercase. I will be clearly showing you this approach while we are going with the code. Okay, we can use the inbuilt function here, but also you want to know this also, okay, for your understanding purpose. Fine. Now after finishing this entire thing, now I will be shifting my weight pointer, that is starting from here, right, to this A. Okay, and again I am going to traverse from this word. So my yellow pointer, that is going on traversing, right? So now it is at A. Whether A is a space, no. Whether R is a space, no. Whether O is a space, no. Whether R is a space, no. Whether the space, yes. So now I will be giving my blue pointer here. Okay, now again, whether these two A are same, yes, it is same. So go ahead. R is same, yes. So go ahead. Now both are at the same point. Now I can tell you that it is also a palindrome, so I will be increasing by 2. Okay, now my weight pointer will be going here back to this here. The current yellow pointer is plus 1. So yellow pointer is like a traversing each and every elements. Okay, while the blue pointer will be the elements front or that element. I will be telling you what is meant by blue pointer in further example. So and white pointer will be the starting point of the word. Now hope you understand, right? Yes. So here again I will be traversing whether it's space, no, and then here comes the space. So whenever we are encountering a space, we will be making our blue pointer to look at the before element. Okay, now whether T and S are same, no, at this point I don't want to do anything. I just make my white pointer to come here, that's it. Okay, again I want to traverse. So whether this M is space, no, here also no. Then whether this is a last word, yes, but we cannot find the last word by using a space, right? So we want to go with the alternate approach, but the last character, this index, so last character index, so last index will be equal to length of the string minus 1, right? By using this condition, I want to give a check condition. If the current character is the last index, then what should I do? I should be making that as my blue pointer. So that's why I have clearly said that the blue pointer will not always be the current yellow pointer front. That means current yellow pointer minus 1. Okay, it can be also in that yellow pointer when it is a last word. Hope you understand this. Now check whether these two are same. So whether M and M are same, yes. Whether A and A are same, yes. Again here L same. Here A same. Again Y and Y, it is both in the same point. So we want to stop here and make this as what? 3. Now traverse further. So there is nothing. So stop here. So what is my result? It will be 3. Hope you understand this solution. Now tell me what is the time complexity. So time complexity will be going to O of n, because we are just traversing the entire word 2 times. Okay, if you clearly observe this, we are almost traversing up to 2 times, which means n plus n, which is equal to n. So it will be only n. Okay, and what is my space complexity? Space complexity will be O of 1. That's why it is an optimized solution, while the brute force approach takes some space to store each and every words, right? Hope you understand this solution. Now let us see the code so that you will be so clear on it. Okay, fine. Now for this question, we don't have any platforms for this code execution. That's why I'm taking the online compiler, and we want to take the Java programming for Zoho interviews. It will be perfect. Okay. Now public class palindrome word counter. So this is going to be my class. It is just a skeleton, that's it. Okay, and this is going to be my member function. This is going to return me how many palindromic word are present in the given sentence, okay, or given string, whatever. Now int result is equal to 0, int f is equal to 0. So f is my weight pointer. In example itself I told you with some weight pointer, right? So this is going to be my weight pointer. Sorry, it is not Python, it is Java. Okay, fine. Now this result going to be my result, and this I, right? So this is going to be my yellow pointer. I am just going with the drawing explanation. That's why I'm telling you yellow pointer. Don't go on in interview and tell that this is a white pointer and yellow pointer. Okay, just understand the solution. That's why I'm just telling this. Okay, fine. Now this R, right? This R going to be my blue pointer. Fine. Now hope you understand, right? Now I'm just checking whether the current character of the string is space. If it is space, what should I do? I should be allocating the blue pointer, which means I minus 1. Okay. Now int left is equal to f and int right is equal to r, and I'm going to start my palindrome program. So initially this palindrome is true. Okay, it is a flag variable, and then while left is less than right, I'm just go on checking whether the left pointer and the right pointer are same. If these both are not same or they both are different, then I will be making this as false and break. Okay, so this is the right way to check them whether they both are same or not. Okay, or else you can also use your own user defined function. Okay, that's pretty much easy. You just lowercase. You want to check whether it is a lowercase. If it is a lowercase, just leave as it is. Okay, and if it is a uppercase, then do what? Uppercase plus 32. Then it will be converted to the lowercase. Or else you can also do in ulta. Like you want to check whether the given is uppercase. If it is uppercase, then do what? Just leave as it is. Okay. If it is a lowercase, then do what? Minus 32. It is not a big deal. Again, it is a small code. That's why I'm just telling in the oral way. Okay, fine. Now, then in each and every iteration, I want to just update my pointers. So left will be +1 and right will be -1. And if is palindrome, then I will be increasing my result +1. Okay, fine. Now my f will be I +1, which means my weight pointer will be updating. Okay, fine. If the current word is the last word, that condition, then also what we will be doing? We will be doing as the blue pointer will be as it is at I, which means yellow pointer. That's why I'm just assigning what? R is equal to I itself. Rest of the thing will be same as we saw in that previous example. Okay, so instead of writing this much code, we can also shrink it as much as easy. Like, let me just shrink it so that it will be more looking more good. So instead of putting these all, okay, I will be just removing this. So if it is then int r, so r will be my not a local variable, it should be here. So int r, that's it. Okay, r here, r there, then here comes this, then its corresponding bracket will be removed. Now for better coding understanding, for code neatness, I will be indenting this. Fine. Okay, we can also write like this. Okay, so if the current thing is space, okay, then my r will be I -1. If not, it is a last word, then we are going to do this. Okay, but it will be checking each and every time, right? Okay, or else we can use here like, just move this one time. And let me add here, like, if the current character of I is equal to a space, or I plus 1 is equal to s dot length of. So we can better use like this. Okay, so if these two conditions is satisfied, sorry, any one of these condition is satisfied, then what should I do? I should be going inside and checking whether which condition is satisfied, so that the code will be looking in compact manner. Okay, it is not about the logic, it is about all about the coding compactability. Okay, so here comes a conditional bracket. I hope this code is pretty much good for you. You can understand this code. So if you not understanding this code, try it in your own way, and you cannot come with your solution, then just comment below. I will be giving the entire code in the comment section. Okay, and also you can just go to the description and just check out this code. I will be giving this code in the description also. Fine. Almost my aim is to just tell you the logic, and you want to write the code. Okay, it is not like you will see the code and write it. No, you want to just see the logic and learn it, and you want to implement the code. That's it. Okay, so let me submit it. So r is equal to I. So where, so here I redeclared. Already we declared, right? So it is not allowed. Okay. So we want to dummy initialize. Okay. Yes. So it is like we want to initialize in a dummy manner, so that it will be not giving the error. It is giving the error like you might not initialize the R. Okay, but we know that either this condition or this condition will be satisfied if once it is this condition is true, right? So that's why we are giving like this. Fine. So hope you understand this solution. It is like you want to understand the logic first. Okay, it is not about the code. Okay, fine. So to know about these kinds of algorithms, just go and search in my YouTube channel. And if you really like this video and subscribe to my channel. Don't skip any videos in this playlist, because all videos will be useful once you are just going into the Zoho interviews. Thank you.